What if I told you that right now, far beyond the reach of your eyes, there is a machine floating in the darkness of space, a machine that can literally look back in time? Not in theory, not in imagination, but in reality. A machine so powerful it captures light that began its journey billions of years ago, long before Earth even existed. Light from a time when there were no humans, no planets like ours, just the early universe taking its first breath. This is the James Webb Space Telescope, a $10 billion machine built with one purpose: to see the past of the universe. For thousands of years, humans have looked up at the night sky and wondered what lies beyond. Ancient civilizations saw patterns in the stars and created stories to explain them. Later, scientists began to study the sky more carefully, building instruments to bring distant objects closer. Each new discovery answered some questions, but created even bigger ones. Then came a simple but powerful realization: light doesn't travel instantly, it moves at a finite speed. When you look at the sun, you're seeing it as it was about 8 minutes ago. When you look at distant stars, you're seeing them years, decades, even centuries in the past. And when you look at galaxies billions of light years away, you are literally looking billions of years back in time. That idea changed everything. Because if we could build a machine powerful enough to detect extremely distant light, we could witness the early universe itself. We could see how the first stars formed, how the first galaxies came together, how everything we know today began. But creating such a machine would be one of the most difficult engineering challenges in human history. It would take decades of planning, thousands of scientists and engineers, new technologies that had to be invented from scratch, and a budget so massive it would become one of the most expensive scientific instruments ever built. Finally, after years of delays, testing, and near failures, in December 2021, the James Webb Space Telescope was launched into space. But unlike previous telescopes, it didn't stay in orbit around Earth. Instead, it traveled over 1 million miles away to a precise location known as the second Lagrange point, a place where the gravitational forces of Earth and the Sun balance perfectly, allowing the telescope to stay in a stable position while orbiting the Sun along with Earth. Why go that far? Because Webb needed darkness, it needed silence, it needed to escape the heat and light of Earth and the Sun to do its job properly. Once it reached its destination, something incredible began to happen. The telescope started unfolding. Because it was too large to fit inside any rocket fully extended, it had to be carefully folded like a giant piece of cosmic origami. In space, step by step, it deployed its components. Its massive golden mirror unfolded into 18 hexagonal segments, forming a surface over 6 meters wide. Then came its most critical feature: a giant sun shield the size of a tennis court. Made of multiple thin layers, it blocked heat from the sun, allowing the telescope to cool down to extremely low temperatures. This was essential because Webb doesn't see the universe the way we do. It sees in infrared. Human eyes detect visible light, but much of the universe is hidden behind dust and gas. Infrared light can pass through these barriers, revealing things we could never see before. Even more importantly, as the universe expands, light from distant galaxies stretches, shifting into infrared wavelengths. That means the oldest light in the universe, the light from the very first galaxies, can only be seen with an infrared telescope like Webb. And when Webb finally opened its eyes, the universe revealed something extraordinary. Its first images stunned the world. In a single frame, Webb captured thousands of galaxies, some so distant that their light had traveled over 13 billion years to reach us. These were not just distant objects, they were snapshots of the early universe, showing us what it looked like not long after it was born. Imagine that for a moment. You were not just looking at space, you were looking at history. You were seeing moments that happened billions of years ago, finally arriving here after an unimaginable journey. It's like receiving a message from the beginning of time. But what made these discoveries even more fascinating is that they didn't fully match what scientists expected. Some galaxies appeared larger and more developed than they should have been at such an early stage of the universe. According to existing theories, galaxies were supposed to take much longer to form and evolve. Yet here they were, already complex, already structured. It was as if the universe had grown up faster than we thought. And that raised new questions. Was our understanding of the early universe incomplete? Were there processes happening that we still don't understand? Or is the universe itself more mysterious than we ever imagined? Webb didn't just challenge our knowledge, it expanded it. Then it turned its focus to regions closer to home, massive clouds of gas and dust known as nebulae, where new stars are born. These regions are often hidden from visible light telescopes, appearing dark and opaque, but Webb's infrared vision allowed it to look inside them. What it found was breathtaking. Inside these clouds, stars were forming in incredible numbers, bright points of light emerging from darkness, surrounded by swirling material. It was like watching creation itself in action. For the first time, we could see the birthplaces of stars in stunning detail. And then, Webb looked at something even more intriguing: exoplanets, planets orbiting stars outside our solar system. For years, scientists have been trying to understand whether these distant worlds could support life, but studying them has always been difficult. They are small, faint, and often hidden by the brightness of their stars. Webb changed that. Using advanced instruments, it began analyzing the atmospheres of these planets. It detected molecules like water vapor, carbon dioxide, and methane, key components that could indicate habitable conditions. This doesn't mean we've found life, but it means we are closer than ever to answering one of humanity's biggest questions: are we alone in the universe? And yet, beyond all the science and discovery, the James Webb Space Telescope represents something deeper. It represents curiosity, the desire to understand, the need to explore beyond our limits. Because everything Webb is showing us existed long before we were here. The light it captures has been traveling through space for billions of years, crossing unimaginable distances, surviving cosmic events, and somehow reaching a small, fragile planet where we built a machine capable of seeing it. That alone is extraordinary. It reminds us how small we are, but also how powerful our curiosity can be. Because despite our size, despite our limitations, we built something that can look across time itself. But the story isn't over. In fact, it's only just beginning. Webb continues to observe the universe, collecting data, sending back images, revealing new mysteries. There are still countless regions it hasn't explored, countless questions left unanswered. Somewhere out there, light is still traveling towards us, light that began its journey billions of years ago, carrying information about events we have never witnessed. And one day, Webb might capture it. One day, it might show us something completely unexpected, something that changes everything we think we know about the universe. Because the truth is, the James Webb Space Telescope is not just a scientific instrument, it is a time machine. Not one that takes us physically into the past, but one that allows us to witness it, to see the universe as it was long before Earth, long before life, long before us. And in doing so, it helps us understand where we came from and where we might be going. So the next time you look up at the night sky, remember this. Somewhere far beyond your vision, a golden mirror is quietly observing the universe, capturing ancient light, revealing hidden truths, and slowly telling the story of everything. A story that began billions of years ago, and that we are only just beginning to understand.